Hi everyone, this is Janine aka Janine The Tutor. As you know, now is a very difficult time for each one of us, whether you're in middle school, high school, or university. Many students and families are deeply affected by the recent school closure, and as a part of OneClass, we are very fortunate that we are able to adapt to the situation quickly, and that's why we want to extend our helping hand by running free and daily classes for math and chemistry from grades 11 to first year college and university. In addition, we are also giving away 100,000 hours of free private tutoring. So if you're interested, make sure to scroll down below and book your time slot. So, yeah, just before we get started, I hope you are all well in the comfort of your own home and you're excited to learn math with me. So, for today's class, we will be covering geometry. So, we'll start learning about similar triangles. Okay, so you know what to do. Hopefully, you guys can hear me coming through and you can see my screen. Okay, so for the first question, I guess we can kind of define what similar triangles first before we even get into this question. So, how do we know if two triangles are similar, right? So, in that case, we're referring to the angles and also the sides of the triangle, right? So, for example, if we're comparing, let's say, JKL and MNO, how do we know if these two triangles are similar? And also, just so you know, the symbol for similar triangles, right? When two triangles are similar, we actually use this symbol over here. So, yeah, which is like a squiggly line. So, as you can see, if two triangles are similar, that means you have proportional sides, right? So, for example, you need to think of a factor, for example, 3. When you multiply that to 3, you get 9. Does that make sense? So that's what you do. And then it's very similar to all of the sides as well. So for example, if you're thinking about 3, right? When you multiply this to 3, you need to get 9 over here, right? So let's say you wanted to find line segment or this side, which is MN, right? So how do you know what this is? Well, if you know that you're multiplying this to 3, right? So 3 times 3 to get 9, that means you need to think of a number when you multiply to 3, you get 6. So that's why we know that this has to be 2. So when I say proportional, this is what I'm referring to. So the sides needs to be proportional. And for your angles, right? Because you know that this is 75 degrees, that means your angles within your two triangles, they need to be exactly the same, right? So if you have 75 degrees, this has to be 75 degrees. And if you have 60, therefore you know that this should be 60, right? Does that make sense? So similar triangles, basically your sides are proportional, but your angles would be exactly the same. Okay, great. So now, if we're referring to, let's say, angle L, right? So this angle, we don't really know right now. I mean, it doesn't really tell us, right? So how do we find angle L, right? So we know that the sum of the interior angles, they're supposed to be 180 degrees, right? So in that case, you would add 75 plus 60, right? So we can do that right now. So 75 plus 60, that's equal to 135, right? And in order for you to find angle L, you would have to take 180 minus 135. So 180 minus 135 is actually equal to 45 degrees. So now you know that this is 45 degrees, right? Because to find angle L, you would have to take 180 minus 75 degrees plus 65 degrees. And we know that this is equal to 45 degrees. And because again, we're saying that angle L, right, is going to be exactly the same dimension or measurement for angle O, right? Because the angles of two similar triangles are exactly the same. So this is 45 degrees. Okay, so now that we know that by now, right, we still have to find what the dimension is for LK, right? So how do we find the dimension for LK? Well, remember how the factor that you're multiplying to get 9 is 3? That means if you have 1, right, for ON, that means you need to multiply 1 times 3 to get 3. So that means the dimension of LK is 3 units. Okay, great. So you kind of have the gist of or you kind of understand now what similar triangles are. So maybe we can actually expand our knowledge, right, by looking at the three types, as you can see here, the three types of similar triangles. So if you're referring to SSS, right? So probably in class, you've probably heard your teacher talk about SSS, SAS, and AAA over here. So the only difference between the three is how I guess the triangles, right, in this case, how the triangles are similar to one another. So the first case being side, 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 right? So if you're looking at this side, right, so these two triangles over here, you know that this is 10, this is 5, right? You know that they're proportional, right? This side, 8, is also proportional to this side, which is 4. And then you have 12, right, which is also proportional to 6. Does that make sense? And what is the factor that you multiply to this triangle so that you get 10, 8, and 12, right? So you need to multiply by 2, right? So 5 times 2, you get 10, right? 4 times 2, you get 8. And finally, 6 times 2, you get 12. So this is your side, side, side triangle. So you can actually say that they're going to be proportional, right? So all three pairs of sides are proportional. So that's when you have side, side, side. Okay. So what about side angle side, right? So for side angle side, if you're looking at this triangle and also this triangle, right? So essentially, you know that this is your angle over here, which they've indicated in between the side of 9 and the side of 6, right? So what they're saying, on top of this being proportional, right? So you have two pair of sides which are proportional to one another, right? You actually have an angle between them that is congruent or exactly the same, right? That's what congruent means, right? In math, it's exact same. So if you're saying this is 50 degrees, then this needs to be 50 degrees as well. So for side angle side, that means you have two pairs of sides that are proportional and on top of that, angles between them. So B slash N means between, okay, I like to abbreviate terms, or actually words rather. So angles between them are congruent. So this is the congruent symbol, right? We need to get used to looking at symbols, right? Because this is math after all. So yeah, that's what side angle side means. Two sides are proportional, and then on top of that, you have an angle in between them that's congruent. Great. So once we have this, okay, so typically this is not really called AAA, right? The only reason why this is called AAA is because if you have two angles, so say for example, you're looking at this angle, right, which is congruent to this angle. That's why you have that two arcs over there. And then for this one, there's just one because you're saying that this angle is equal to the other angle, which is here, right? The only reason why this is called AAA, right, but technically it should be AA, is because if you know that the two angles, right, the two pairs of angles over here is congruent to the two pairs of angles over here, that means you're saying that this angle, right, because it's the only angle that's left, therefore this needs to be the same as this one, right? If these two are congruent, these two meaning they're the same, right? This last angle over here, because it's the only angle that you have, therefore this is going to be equal to this. Does that make sense? So that's why when you have the triple A, right, or they can actually say that this is just AA, right, to begin with, but because we know that in a triangle you only have three angles, therefore the last one would be the same as this one. So you're going to say that two pairs of angles are congruent. And because you know that the two pairs of angles are congruent, then if two angles are congruent, then all three will be congruent. Let me just say therefore, right? So in math, for therefore, we use the symbol. It's like three dots and it looks like a triangle. So all three pairs of angles are congruent as a result of this being a triangle. Okay, so hopefully that's clear. So again, in terms of similar triangles, we have three types. We have side, 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 we have side, angle, side, and we have angle, angle, angle. Okay, great. So maybe we can actually look at some, I guess, figures, right, and example questions and see if we can actually apply them. So, first question, we have this, right? So as you can see, because they've explicitly shown us that this angle and this angle, they're congruent, right? And these two angles over here, they're also congruent. Therefore, yes, they're similar, right? And this is based on the angle-angle theory, right? Or corollary. Yeah, let's just keep it as triple A, so great. Yeah, so for this one, right? So here's the thing. Anytime you're doing questions like these ones, right? It doesn't mean that they show you the exact same triangle, which is like a smaller version or a bigger version of the other one. And then if you look at the numbers, right, you always have to look at the numbers if they're proportional. Because I think I see a lot of students, what they do is they just look at the figure for some reason and they assume things. Okay, so in math, this is not about assumption. You just have to make sure what you've seen, right? You need to provide evidence that the sides, right? In this case, if you have the side, 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 they need to be proportional, right? The three sides need to be proportional. Otherwise, if they're not proportional, then they're not similar. So if you have 7 and you have 525, so maybe we can calculate the ratio between the two. So if you have 7 over 5.25, so that's this and this, right? And also, just keep in mind that whenever you're taking the ratio, right, you have to make sure that you're corresponding that to the exact same side. So you can't just take the ratio of 7 and be like, okay, so we're taking the ratio of 7 and 9, which is not even the same side that you're looking at, right? So it has to make sense again. So if you have 7 and you have 525, that means it's going to be 7 over 525. And then finally, if you have 12 and 9, right? So say for example, you can say 12, right, over 9. And also again, if for example, you're looking at 7, right, which is the larger dimension, and then you have 525, right? And then for 12 and 9, right, you need to keep in mind that if you're starting your numerator with the larger side or the longer side rather, that means you need to keep it consistent. So if this is 7, right, which is coming from the larger triangle and it's a longer dimension as opposed to 525, therefore your 12 needs to be the one in your numerator as opposed to 9. Does that make sense? And then if you're using 14, then this has to be 14 over 10.5. You can't have these two and then be like, okay, so the last ratio that I'm looking at would be 10.5 out of 14. Well, that's wrong, right? Unless you actually start with 525, right, over 7, and then you have 9 divided by 12, and then you have 10.5 divided by 14. Okay, so maybe we can calculate that. So 7 divided by 5.25, that's equal to 4 over 3, right? When you simplify these two, that's 4 over 3. And if you have 12 over 9, that's equal to 4 over 3 as well. And if you have 14 over 10.5, that's equal to 4 over 3 as well. So yes, these two triangles are similar, right? So we can say yes, and they're similar based off of the side, side, side theory. Okay, so I guess we've pretty much answered the first two questions. Okay, so let's move on to number 3. So we need to state if the triangles are similar by side, 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 angle, side, or the triple A. And if the triangles are not similar, then we write no. Okay, so let's say, right, we're taking the dimension coming from the smaller triangle as opposed to the larger triangle, which we kind of did from this question, like from part B. Okay, so I'm taking 3 divided by 4.5. So 3 divided by 4.5, and then I know that I'm looking at 6 now, then this is divided by 9, and you have 4 divided by 6. So this is the right way. So if you started with your numerator with the smaller triangle, right, or the shorter dimension, you need to make sure that your bigger dimension follows for all 3 fractions. Okay, so that's 3 and over 4.5, and then you have 6 divided by 9, and then you have 4 divided by 6, right? So take your calculator and punch this in. So this is 3 divided by 4.5. So this is equal to 2 over 3. And then you have 6 over 9, which is also equal to 2 over 3. And then you have 4 over 6, which is also equal to 2 over 3. So because they're equal to one another, right? And you can actually say that it's proportional, right? So it's yes, it's proportional by the side, side, side. Okay, so oh, and also, just so you're wondering, right? So I know we've set up these numbers in terms of fractions, right? But maybe if there is a question from you guys, like you're probably wondering, okay, so Janine, so instead of 2 over 3, right, are you supposed to keep it in terms of fractions, right? So the only reason why I'm keeping this in terms of fractions is because if you turn this into a decimal number, you're going to see that this is actually equal to 0.6 and it's repeating. So that's fine too, right? You can always express your answer in terms of decimals, right? At the end of the day, you just want to see if they're proportional, and that's why I'm just recommending to convert this into fraction because you don't have to deal with the decimal counterpart. But that's fine. Yeah, both are acceptable. As long as you prove that all three are 0.6 and 6 is the number that's repeating, that's fine too. Okay, so this one, I don't think you need to really solve for anything. So we can just say this is a yes, right? And based on the figure, we can say that this is these two triangles are similar, right? Why? Because of the angle, angle, angle. Okay, so now we're looking at this, right? So interestingly, we have side, angle, side, right? So we know that just by looking at the two triangles right off the bat, we know that the angles are congruent, right? That's why you only have one symbol, right? So maybe we can test out and see what happens to your side, right? So I'm taking 4, right? So 4 divided by 6, and then I'm also evaluating what happens when you have 5 divided by 7.5, right? So 4 divided by 6 would be 2 over 3. And then you have 5 divided by 7.5, which should also be 2 over 3 if they were similar. So this is 2 over 3. And yes, it's similar, right? And this is based off of side, angle, side. Okay, I guess you can see right off the bat, right? These two angles, they're congruent, right? And on top of that, the right angles are also congruent. So therefore, for part D, you can actually say based off of AAA, right? So yes, they're similar based on AAA. Yeah, so as you can see, anytime you have the triple A's, right, it's all about looking at the figure, right? And sometimes I know for some diagrams, they don't really show you that 90 degree angle, and sometimes they don't show you this angle. So you just have to pay attention in terms of the numbers. So for example, they're saying this is 75 degrees, right? And then this is another angle, right? And they need to be exactly the same, just so if they're similar. So it doesn't have to necessarily be in terms of this symbol, right? For you to understand or evaluate whether something is similar or not. Okay, so we have part E. So we have this angle and this angle, right? The same, as you can see, right? So maybe you can actually figure out if the dimensions are actually proportional, right? Whether your sides are proportional. So if you're looking at 5, right? So, okay, and also think about this. Because you're referring to this angle and this angle, right, over here, so it has to make sense. When you're comparing this 5, which side are you comparing it with? Is it 1.75 or 2.5? I would say you're comparing it with 2.5. Because when you rotate this angle, right, let's say clockwise, right, for this angle to be on top, you need to make sure that you're doing the exact same thing, right? You can't have one angle here and you're comparing 5 and 1.75 just because they're on the left side, right? So in that case, you would take 5 and this is divided by 2.5. So the larger triangle would be 5, and then you have 3.25 coming from the larger triangle. This is divided by 1.75. So now we see that you have 5 divided by 2.5. So that's equal to 2. And then you have 3.25 divided by 1.75. So that's equal to 13 over 7, right? So it's pretty obvious that the dimensions, they're not proportional, right? So if they're not proportional, therefore they're not similar, right? So it's a no. Okay. So yeah, it's always a good, I guess, good way to check, right? For example, just by looking at the angle, it doesn't mean that it's already side angle side, right? You actually have to check your sides, right? If they're proportional or not. Okay, by the way, for F, as you can see, it's down here. So, okay, as you know, we can probably test out side, 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 right? And see which one. Okay, so for F, right, as you can see, if you try to rotate this now, instead of rotating this clockwise, you would have to rotate this counter. Yeah, counterclockwise, right? So if you have 10.2, if you rotate this counterclockwise, you're going to compare that with 7.65. So we have 10.2, right? I'm taking the larger triangle. Again, there is no preference, right? If you want to take the smaller triangle first, I mean the dimensions of the smaller triangle, go ahead. Just make sure it's consistent for all three fractions or ratios. So if you have 10.2, that's going to be over 7.65. Okay, so we have that. That's done. And then I guess the base in this case, you have 4.6, so you would have 4.6, and this is divided by 3.45, right? Let me mark an X over here so I know that I'm comparing these two. And then finally, you see that you have 12 and 9.25, right? So 12 over 9.25, right? So dividing 10.2 with 7.65, so that should give you 4 over 3. So that's 4 over 3. And finally, if you have 4.6 divided by 3.45, that's equal to 4 over 3. And then if you have 12 divided by 9.25, right? Okay, so here's the thing. This is where things become off, right? So if you have 12 divided by 9.25, if you type this into your calculator, you would get 48 divided by 37, right? So if it's 48 over 37, if one throws you off, that means this whole thing, right? These two triangles, therefore, are not similar. So it's a no. So F is a no. Yeah, it doesn't mean that if two sides are proportional, you can actually say that it's similar based off of the SSS. No, because if one side is not proportional, right? If it doesn't follow, like if it's not like 4 over 3 for all three, that means you can't say that these two triangles are similar. It needs to be exactly three sides, yeah. I mean, because that's the rule, right? It's called SSS, and because of that, right? Okay, great. So, yeah. And I think the most confusing part for the majority of the students taking geometry is when they start rotating, I guess, the questions. So, say, for example, this one, you're not really sure how to position this because I know that it takes time for, I guess, your brain to actually picture that. So, it's fine, right? But as long as you're able to recognize, so think about this. If you have 15, then you have 12, right? So, you need to make sure that this angle is in between them, which is right here. And then on top of that, because you're comparing this, right, 12, so which one would be the best one? It would be 8, right? It's not 10, right? Because for this, so if you rotate this counterclockwise, right, that means you're comparing 12 and 8, right? To see whether they're proportional or not. And you're comparing 15 and 10 to see whether they're proportional or not. And also, you also have to, I guess you have to put some common sense here because if you have 8 and 10, right, you cannot say that you're comparing 8 and 15 because obviously we know that 8 is going to be shorter compared to 10. So that means when you're comparing 8 and 10 with 12 and 15, you know that 8 is being compared to 12 as opposed to 15 because if it's the shorter dimension, then 12 must be compared with 8. Does that make sense? As opposed to 15. So you know that 15 needs to compare to 10. Okay, great. So you have 8 over 12 and So we're taking the smaller triangle first, right? Divided by 12, and then you're taking 10 over 15, right? So let's see, 8 divided by 12, that would be 2 over 3, right? And then if you have 10 divided by 15, that's equal to 2 over 3. So yes, they're actually similar, right? So yes, it's similar based on side angle side. So that's for part G. Okay, so this is the part where I start, I guess, referring to dimensions, right? So for H, remember how whenever we're comparing angle, angle, angle questions, we just look at these types of figures, which only shows us, so say for example, this one, right? This is basically similar, right? The two triangles, but they're not really telling us exactly what the angle is, right? We just assume just by looking at the figure because we know that we're comparing this, and we know that the 90 degrees and 90 degrees over here, they are congruent, right? Or exactly the same dimension. So what if they change up the question and they gave us real measurements, right? Like 72 degrees, and then we have 33 degrees, and so on and so forth. Okay, so as you can see, if you have 72 and you have 33, right? So remember the theorem that we were talking about, which is the angle, angle, angle. The two pairs of angles, they need to be the same measurement, right? And for two pairs to be the same measurement, therefore the third angle in that triangle, it needs to be congruent to this other triangle, right? So once you start seeing that the two angles right here, so this is 72 and this is 75 and this is 33 and this is 60, well, you're not supposed to be proportional. It needs to be congruent, right? It needs to be exactly the same. So that's why this is a no, right? Because even if you look for the third angle, right? So let's say we want to look for this third angle. So this third angle would just be 180, and this is minus 72 plus 33 degrees, right? So even if you tried to look for this angle, so 180 minus 72 plus 33, that means you're going to get 75, right? Okay, so yeah, it is 75, but what about this one, right? So for this, you would take 180 degrees minus 75 plus 60. So that's equal to 45 degrees. So even if this is 45 degrees, and yes, you do have an angle which is 75, which is congruent to the 75, it doesn't change the fact that you have 45 degrees over here and you have 60 degrees, and you have 72 and 33 degrees over here. They're not congruent, right? Therefore, you can say that they're similar, right? Based on the triple A's, right? Which is angle, angle, angle. So yeah. You can't just have one. It has to be three angles. Or at least two, right? For you to tell that the third angle would be the same. Okay, so now we see that we have a 90-degree angle here. There is a 90-degree angle here. So that means we're comparing the 12.5 with 5, right? And 6 with 15. Does that make sense? Because if you try to rotate this counterclockwise, right? Going this way, you're going to see that this is going to be 5 divided by 12.5, right? I'm comparing the smaller triangle to the larger triangle, and I'm taking 6 over 15. And let's see what we're getting. Oh, and also, yeah, just as a reminder, I think I've emphasized this so much, right, earlier. So I know that this is, I mean, yeah, it looks like it's a side angle side theory, right? So if you have side angle side, right? And you're probably wondering, okay, so we do have a 90-degree angle over here. So can I just pick 15, right? And 5, and I compare the two, and I can just take 6 and 12.5 because, I mean, they're adjacent, right? They're exactly side by side, and you just have an angle over here, which is 90 degrees, right? So does it change the fact that they're going to be proportional or not? No, because you can't do that because you're referring to 5, right? Which is the shortest, yeah, I guess the shorter dimension compared to 6, right? So this is the shorter dimension, so that means you're supposed to compare 5 with 12.5 as opposed to 6 and 15. Does that make sense? Because you can't just take 5 and 15 because you know that 15 is a longer dimension. Therefore, you're supposed to compare that with 6 because 6 is a longer dimension compared to 5. So that's why I'm setting this up as 5 over 12.5 and this is 6 over 15. Okay, so 5 divided by 12.5 is equal to 2 over 5, and you have 6 over 15. So 6 over 15 is also 2 over 5. So you can actually say that yes, it's similar, right, based on side, angle, side. Okay, so I guess we have measurements of angles now, right? So we can see that this is 85, 85. And maybe this angle might turn out to be the exact same as this one. That's why we need to find this third angle over here. So let's look at the smaller angle first. Sorry, smaller triangle first, right? So what is this angle over here? So if you have 85 and you have 42, so all you do is take 180 minus 85, and this is minus 42, right? So this is actually 53 degrees, right? Okay, so again, how do I get that? It's 180 degrees minus 85 degrees plus 42 degrees. So once you've calculated and punched this into your calculator, this is supposed to be 53 degrees, right? So as you can see, this is 53 degrees, so you're most likely going to be similar, right? So maybe we can find this. So this is 180 degrees minus 85 plus 53. Yeah, I guess it's pretty obvious now because if you have 53, the other one must be 42, right? So 180 minus 85 minus 53, that should be 42 degrees, right? Because remember, based on the theory earlier, if you're looking at angle, 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 right? And this is similar, by the way. So if the two angles, so 85 and 85 respectively, and if you have 42 and 42, if the two pairs of angles are congruent, then that means the third angle is also congruent, right? That's why we know that it's supposed to be 53 degrees for the third angle. Okay, so for part K, right, again, because we're given with side, 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 right, we need to check our dimensions. So what I'm going to do, right, is to assess which one is going to be smaller, which one is going to be the longer dimension, right? Because I guess it gets harder to tell, especially if you look at a triangle like this, which side are you comparing to which side, right? So think about it. You know that the smaller triangle, among the three dimensions for the sides, the longest side, 8.4, over here, this needs to correspond with, let's see, with 12.6, right? Because if you look at the larger triangle, if you have 7.05, you have 9.15, and you have 12.6. Well, the longest dimension in this larger triangle is 12.6. Does that make sense? So that's why if you have 8.4, you need to compare that with 12.6. And we're going to set that up right now. So this is 8.4 divided by 12.6. Okay, so the next ratio that you need to set up is looking at the shortest one. So the shortest one would be 4.7, right? And if you're looking at the larger triangle, if you're comparing 7.05 and 9.15, you know that the shortest side would be 7.05, right? So therefore, you need to compare 4.7 over 7.05. And then if you have this 6.1, well, this is the last side. Therefore, I'm comparing this and this. So this is how I like to compare my sides, right? If they're proportional or not. You need to have an intuition just by looking at the figures. Well, if this is the longest side, therefore you need to compare that with the longest side, because you don't get I guess a hint here in terms of, you know, this is the angle, therefore you can actually just kind of infer that, okay, if I have an angle in between, then that's going to be equal to this. Does that make sense? So that's why you need to infer based on the length of your side. So if it's the shortest one, you need to correspond that with the shortest one, and if it's the longest one, right, it needs to correspond to the longest dimension. Okay, so where were we? So we were looking at 9.15 and 6.1. So we said we're looking at the smaller triangle first, therefore this needs to be 6.1 divided by 9.15. Okay, so once we have that set up, we have 8.4 divided by 12.6, and that's equal to 2 over 3. If we're looking at 4.7 divided by 7.05, that's equal to 2 over 3 as well. And if you're looking at 6.1 divided by 9.15 rather, so 6.1 divided by 9.15, this is also 2 over 3, right? So as you can see, they're all proportional, right? So yes, we can say these are similar triangles based on SSS. Okay, so for L, right, I think it's pretty obvious that because they're saying that this contains two tick marks, right, therefore it's not going to be similar to any of these, right? Therefore, that's what we're going to do. We're going to say that they're not similar, right? We don't really need to calculate anything because it explicitly tells us that this is not congruent to any of the two triangles. Sorry, any of the two angles, right, in this triangle. Okay, so for number 4, we're going to do the exact same thing. Identify, right? If the triangles are similar by SSS, SAS, or AAA. If the triangles are not similar, then we write no. Okay, so now that we have this triangle over here, so I guess it gets a little bit challenging now. So how do we know if this is similar or not, these two triangles, and they're combined, right? So think back to your special angles, right? Remember your X pattern, right? That's what we're going to do right now. So if you have an X pattern, that means this angle would correspond to this angle, right? So if this angle was whatever degrees this is, right? We don't really care about the dimension right now or the exact measurement, right? As long as we know that in this triangle, right, two angles or the pairs of angles are basically congruent to the opposite triangle over here, right? If you have at least two angles that are congruent, that means the third angle must be congruent as well. So yes, this is based on AAA. So it's similar. Okay, so now we're looking at this. They're saying that you have an angle here and you have an angle here, and then they're saying that this is 3, then you have 8. Right? So obviously this is a no, right? Because we don't really have any theorem, right, to say that this is just the side and the angle. It needs to be side, angle, side, right? And also, even though they're side by side, right, you're probably wondering, okay, so what about this side, right? Could it be similar, right, or proportional, right, to this? Well, you can't really say that because they're not giving you the dimension. So you cannot infer anything just by saying that because they're side by side or they're sticking together. Okay, so now we're going to look at a triangle which is basically, I guess, coinciding, right, which is on top of one another. So if you have this triangle over here, right, so first of all, you're not going to set up a ratio and be like, okay, so I'm just looking at 5, right? And then this is basically being compared to 3. So that's not the way to go, right? So first of all, you need to say that if you have this angle over here, right, you're looking at this angle. I'm comparing this 3, right, to my larger triangle. So you need to look at the bigger picture. So you're looking at the smaller triangle, and at the same time, you're looking at this larger triangle, right? So let's say I'm comparing 3, right, from the smaller triangle, and I'm comparing that to the larger triangle, which is 8, because 5 plus 3 is 8, right? So it's 3 over 8. So I'm comparing the two. So I'm comparing 3 and 8, and then on top of that, I'm comparing 6 and 16, right? So that's how you're going to set this up. You're not comparing 10 and 6, right? It has to be 6 the smaller triangle, and then the larger triangle, which is 16. So 3 divided by 8 and 6 divided by 16, right? So 3 divided by 8 is equal to 0.375, or just 3 over 8. And then if you have 6 divided by 16, that's actually equal to 3 over 8, right? So yes, they're actually proportional. So you can say yes, it's proportional based on side, angle, side. Okay, so let's look at part D. So for part D, as you can see, we have another smaller triangle, which is sort of overlapping with the larger triangle over here. So this is your larger triangle. So if you know that this is 42 degrees, right, and you know that this is 48 degrees, if you were to compare this based on angles, right, because first of all, you know that the two triangles, they need to have, they're both right angles, right, as you can see over here. So if this smaller triangle is a right, yeah, it has a right angle, that means the larger triangle needs to also have that right angle over here. So that means you know that if this is 42, right, this must be 42 as well. And what else? If this is 48, right, this must be 48 as well, right? If you have this as 48, this must be 48 for you to be similar, right? So yes, these two angles are similar based on angle, angle, angle. Okay, so let's try this question. So now you have four, again, it's all gonna be angles and, sorry, triangles, and they're coinciding, meaning they're on top of one another. So when you're going to read this triangle, it has to be the bigger triangle, not this trapezoid over here. Okay, so let's go. So we have this 4.7, right, from the smaller triangle. So that 4.7 is being compared with the whole, or yeah, I guess from this point to this point. So it's the entire side, right? So 4.7 plus 3, that should be 7.7, right? So you're comparing this 4.7 with this whole thing. And then because you're looking at the smaller triangle first, right? This is supposed to be 4, right? And in your denominator, that's supposed to be 6, right? So if you have 4.7 divided by 7.7, that should give you 47 over 77, right? And is this equal to 4.6? No, right? Therefore, they're not proportional. So it's a no for E. Okay, now let's look at this. So we have 9 and 13.5. So first of all, again, remember your pattern. So you have your Z pattern, right? So Z pattern is basically, sorry, X pattern in this case. So X pattern would be over here and here, right? So this angle would be congruent, or it's exactly the same angle as this, right? So maybe we can ask ourselves, okay, so you have 9 and you have 4.5, then this is 13.5 and 3, right? So how do I know which angles to compare? Sorry, which sides do I need to compare, right? So if you have, let's say 3, right? This is 3. I'm going to compare that with 9. Does that make sense? And then on the other hand, because I know that 3, right, is going to be shorter compared to 4.5, that's why I know I'm supposed to compare it with 9. Does that make sense? And I'm comparing 4.5, which is larger compared to 3, and then I'm comparing 4.5 with 13.5 because 13.5 is larger compared to 9, right? So this is 3 and 9, and then on the other hand, I'm looking at 4.5 from the smaller triangle, and that's over 13.5. And let's see what happens. So 3 divided by 9 is 1 over 3, and then you have 4.5 divided by 13.5, that's equal to 1 over 3. Okay, so yes, they're similar, right? So yes, they're similar based on side, angle, side, right? Side, angle, side. Okay, hopefully this isn't too bad, right? It's all about looking at the triangles and see which theory applies. So, okay, great. So just by looking at this figure, we know that if this is 35, therefore this must also be 35, right? So we have 35, right? And maybe we can actually take a look if this triangle over here, right? What is this angle, right? So for us to find what this angle is, so we would take 180 degrees minus 67. Make sure it's in a bracket because you're supposed to distribute the negative sign, and this is plus 35 degrees. So 180 minus 67 minus 35, that's equal to 78 degrees, right? So this is 78 degrees. So how do you find this angle then? Well, this angle needs to be 180 minus 35 degrees, and this is plus 77 degrees, right? So 180 minus 35 minus 77, that's equal to 68 degrees. Okay, so as you can see, even though the 35 degrees, they're equal to one another, right? 67 and 77 or 68, they're not congruent, right? They're not exactly the same angle. Therefore, you can't really say anything about this two triangles being similar, right? So it's a no. Because for you to apply the triple A's, right, the AAA theory, you need to have three angles that are congruent. So you can't say anything about that. Okay, so let's move on to H. So for H, we have, okay, so we need to compare the sides, right? So remember what I said. So just rewind to what I said earlier. How do you know which sides to compare whenever you have a side theory that you need to deal with, right? So first, identify which one is the shortest side, right? And then you're supposed to compare the shortest side with the shortest side of the larger triangle. So let's do that. So we know that it's 3.2, right? If you're comparing 3.2, then that means you're supposed to compare that with 4.8, right? So I'm setting up my ratio, and then the next larger size, right, would be, or longer side rather, the next longer side would be 5.7, right, and 8.55, right? So that's 5.7 divided by 8.55. And then finally, we have 7.3 and 10.95. By the way, the X marks that I'm indicating beside the number or on top of the number is not because it's wrong. I'm trying to use them as a legend. Does that make sense? So if I'm saying this is 7.3, this has to be compared to 10.95. Okay, great. So I've set this up in a way that the smaller triangle, the dimensions of the smaller triangle are in my numerator, and my denominator is basically based from the larger triangle. So if you have 3.2 divided by, so 3.2 divided by 4.8, that should give you 2 over 3. And if you're comparing 5.7 divided by 8.55, that should give you 2 over 3 as well. And if you're looking at 7.3 divided by 10.95, that should give you 2 over 3 as well. So yes, they are similar, right? Based on side. So for I, right, we know that these two are vertical angles, right, which is the X pattern, so they're congruent. And if you're looking at this being 8, right, so here's the thing, right, I know this is a side angle side, but let's say you're not really sure which side you're supposed to compare 8 with, right? So again, you know that this smaller triangle, you're comparing 8 and 7, so you know that 8 is the longer side compared to 7. Therefore, you're going to go and hunt, yeah, you're going to go and look for or hunt for the side that's also longer, right? So if you're comparing 17.5 versus 19.5, you know that 19.5 is the one that you're supposed to compare it with 8, right? And then 7 with 17.5, because between the two dimensions, 17.5 and 19.5, you know that 19.5 is longer. Therefore, 8 must be compared with 19.5, and 7 can be compared with 17.5. Just make sure the dimensions on top are from the same triangle. It doesn't have to be from the smaller triangle. It also could be from the larger triangle. So now we've set this up, right? So we have 8 over 19.5. So let's go and find that. So this is 8 over 19.5. So this is 16 over 39. And then you have 17 divided by, 7 divided by 17.5. Okay, so 7 divided by 17.5 is equal to 2 over 5. So it's a no, right? So they're not proportional, therefore they're not similar. And also, even if the angle for the two, right, for the two triangles, they're congruent, but because the sides are not proportional, therefore you cannot say based on the SAS, right, they're similar. So they're not similar in that sense. Okay, so now we're getting into J, right? Okay, so apparently there's only two left. Okay, so if you have this being 78, therefore you know that this is 78 because these two angles are vertical, right? So maybe we can go ahead and look for this and this. So for this, right, this would have to be 180 minus 48 degrees, right, plus 78 degrees. It's because of this and this, right? So you would have 180 minus 48 minus 78, that's equal to 54, right? So because you know that this is 78, this is 78, and this is 54, and this is 54, right? Without even looking for 48 over here, you can actually tell right off the bat because the two angles are the same and they're congruent, right? From this triangle, right, to this triangle, that means you can actually say that these two triangles are similar without even looking for this. Because if two angles in one triangle is congruent to the other triangle, right, which is 78 and 54, then therefore you know that this must be 48, right? And therefore, the two triangles, they're similar based on the triple A, right? Angle, angle, angle. So it's a yes, they're similar, and it's based on AAA. Okay, so moving on to the last question, right? Again, we have two triangles which are coinciding. So coinciding just means they're overlapping, right? So we're looking at the bigger triangle and we're looking at the smaller triangle. Okay, so here's the thing, because they're giving you that this is 13 starting from here and here, right? And this being 4 and this being 5, right? Because this 5 just refers to this. Does that make sense? Okay, so interestingly, they're not telling you what this is, right? But that's okay, because really all we have to care about is looking at the smaller triangle, right? The dimensions of the smaller triangle. So in this case, you're comparing 4, right? You're comparing 4 with the larger triangle, right? Which is 9, because it's 4 plus 5, and that's 9. And then on the other hand, because you're comparing 4 over 9, right, you're also comparing this 6, right, which is coming from this side of the triangle, so it's 6, and that's going to be divided by 13. So you don't really necessarily need to go and look for this dimension because all you care about is the whole thing, right? So it's only this and 13. So it's 6 over 13. But let's say they're not telling you that this is 6, right? And they're telling you, like, let's say this is 7, right? So if they're telling you that this is 7, that means you need to go and look for this dimension. So you would have to subtract 13 minus 7 to get 6. Because the most important thing here is to be able to find out the dimension from the smaller triangle and as well as the larger triangle. That's why we need to find the dimension for this side, for the smaller triangle. Okay, but going back to the example, we have 4 over 9 and we have 6 over 13. So maybe we can actually check and see if they're proportional. So because you can't simplify this nor this, right? That means they're not proportional, right? So you can not say that they're similar because they're not proportional, right? We don't have any rule to tell whether these two triangles, right, if they're similar or not. So it's a no. Okay, so before we end this class, I just wanted to, show my gratitude by saying thank you so much, guys, for coming in. I know it must be a very difficult time, especially when your classes are being moved online, which is something that a lot of you are not used to. But I hope we are able to cope with this situation better. So by working together, and I really appreciate you guys just sitting there listening to my rant, or I guess teaching for an hour, right, for geometry. But if you found this helpful, and if you know anyone who might want to join us, right, any of your friends, please visit oneclass.com/livestream. So yeah, it's oneclass.com/livestream. So this is where you can actually see my daily schedule, because I do host classes online, right? And they're not just for math, it's also for chemistry, right? So this is where my daily schedule is. And also, there are other talented educators who are also teaching in this platform. So make sure to check that out. And without further ado, I'll see you on my next class. And I do have a class for Algebra 2 coming up at 4 p.m. today. So I'll see you guys. Bye.